going to talk about how to solve by elimination. So with elimination, we are going to be adding equations together. So the first thing that we're going to have to do is decide which variable we want to eliminate from all three equations. Okay. So just like with the substitution problems where we had to substitute in twice, we are going to have those two addition problems after we decide which variable we want to get rid of. So we might have to multiply one or two or all three equations by a number to make that happen. But we do need to do it twice, and we have to get rid of that same variable both times. So as I'm looking through this, we want to pick the easiest variable to eliminate. So I would probably choose to eliminate z for this because it'll be easy to take this 30 equation times a number to get it to be the opposite of either the first or the second one. Now it honestly doesn't matter which variable you pick, but again, if we're trying to think ahead and we want to do the least amount of work, that's what we want to look for. So this means that I am going to start with the first equation. So again, I'm going to eliminate z. Okay. So to do that, I'm going to take equation 1, and then I want this to be a positive 5, so that means I'm going to multiply the third equation by negative 5. So I'm going to add negative 5 times the third equation. Okay, so that first equation I'm not changing, so I'm just going to rewrite it. And then in this third equation, I am taking all of these numbers times negative 5. And again, I would use a calculator so to help you, just so you don't accidentally make an algebra mistake, especially when we're dealing with some bigger numbers. So if we're multiplying everything by negative 5, this will be 25x minus 15y plus 5z equals, let's see, and 17 times 5, 85. Okay. And again, I'm adding those equations together. So z's canceled. This will give me 27x minus 11y equals, and then 18 plus 85 is 103. Okay. And if you need to, you can put a little star by this one because we are going to come back to it. So now we need to use a different pair of equations and eliminate z again. So this time I'm going to choose to use the second and third equation. So that second equation I'm not going to change. Okay. And then to get it to cancel out, this needs to be a negative 2. So I'm going to multiply everything in that third equation by 2. So I'm going to take equation 2 and I'm going to add it to 2 times equation 3. So I'm just rewriting the second equation to start. Okay. And then now I'm taking that third equation times 2. So that will be negative 10x plus 6y minus 2z equals negative 34. Okay. All right, so adding, this will give me negative 13x plus 11y. My z's cancel, and then this will be negative, should be 61. All right, so now I've done my two addition problems. Okay, so again, I can put a little star by that. So now what we need to do is put those together. So my new system that we now need to solve consists of those new equations that we came up with, just like when we did our substitution step. So I have to pair the 27x minus 11y equals 103 and negative 13x plus 11y equals negative 61. So this is that new system that we are solving. Okay. And again, graphically what's happening is we are finding the intersections of these two planes to get this line, and then the intersection of these two planes is this line, and now we're finding the intersection of the two lines to get the point where all three are meeting. So just like before, at this point, we can decide if we want to switch to substitution or continue with elimination. So looking at this, my y's are going to cancel nicely if I just add these together. So if we do 27 plus a negative 13, that is going to be 14x. And then my y's cancel. And then 103 plus negative 61 is 42. And now we are going to divide both sides by 14 to get that x by itself. And that is going to give us a positive 3. All right, so we got our first variable of x equals 3. So now to get our second one, we're going to go back to this system and finish solving it. So I'm going to plug the x in one of the equations to get the y. So it doesn't matter which one we choose. I'm just going to use the top equation. So this will be 27 times 3 minus 11y equals 103. So 27 times 3 is 81. And then we are going to subtract the 81 over to the other side. So negative 11y is going to equal, let's see here, negative 22, positive 22, excuse me. And then when we divide, we end up with negative 2. Okay. All right, so now that I have two of my variables, this is when I go back to one of the original equations, and we're just going to substitute both of these in at the same time to find the third variable. So again, it doesn't matter which equation we choose. So I'm just going to choose the top equation. So I'm going to substitute 3 in for x and then negative 2 into the y. So this will be 2 times 3 plus 4 times negative 2 minus 5z equals 18. So this will be 6 minus 8 minus 5z equals 18. And 6 minus 8 is negative 2 minus 5z equals 18. I need to add the 2 over. So negative 5z equals 20. And then we are dividing both sides by negative 5. So that means z is equal to negative 4. So that is my third variable. And then I still need to write my answer as an ordered triple. So x, y, z. So our point of intersection is at 3, negative 2, negative 4. And that's going to be my final answer for this first example. Okay. So I would go ahead and pause and then start working through this example, and then I will work through it in the next video.